Kumar sir, shall we start?
Manas, we will start. Sir joined.
Okay, good afternoon. Yes, sir. Sir joined.
Okay. Okay.
Yes, sir, I am ready.
Okay, sir. Okay.
Yes, sir.
Start.
Good afternoon, all. So, this session, we are continuing from the first session today, that is Mathematical Foundations for Data Science, handled by Kumar Valan sir. So, I would like to invite Kumar Valan sir for handling session. Sir, you can continue.
Thank you, Rahman, for giving me the
Manas.
another opportunities. Right. So I think it's always a very difficult task to entertain the student as well as a student. It may be either as a student, scholar, or a faculty to entertain in afternoon session. I think all the participant will render the same kind of cooperation that you have rendered in the morning. So with this expectation that I am starting this session from where I stopped in the morning. Okay, whether I am audible first of all?
Yes, sir. Audible.
Thank you. Now, okay, now I am going to share my screen. Just check it out whether it is.
Yes, sir.
Is it visible, sir?
Yes, sir. Yes.
Okay, fine. Okay. So today I am going to educate you how to find the inverse of a matrix and why calculating the inverse of the matrix is such an important task in data science, and using the concept of inverse of a matrix and how certain operations can be made easy in data science, especially in finding out the parameter values. So ultimately, either it may be a machine learning model or deep learning model. We are given with the weights and we have to find the optimal parameter. That's all. I can say like this. So in order to find that particular parameter, the inverse operation plays a very, very vital role. So how to calculate the inverse of a matrix? That is the primary objective for another 20 minutes. But using the programming languages like R or Python or Julia, anything, there are well-defined library functions are there for finding out the inverse of any given matrix. But if you know actually the internal details, surely it will give you a better idea. That is the purpose that I'm going to educate you how to find out the inverse of a matrix from the scratch. Okay. So previously in the morning session, I stopped here. What is a necessity to find a rank of a matrix? So the rank of the matrix determines how many rows in the data set is independent to each other. So obviously all the rows of information should be independent in nature. Then only you can make it as a benchmark data set. If there is a dependency, then automatically we can come to a conclusion that some kind of duplication is there. Okay, so that is the purpose we are going to calculate the rank of a matrix. Sorry. Okay, now I am going to educate you how to calculate the inverse of a matrix. Especially the inverse of the matrix is highly used to solve large number of equations. I can say large number here, large number of features. If your data set consists of more number of features, that is a high dimensional data, then at the time inverse plays a very, very vital role in calculating the corresponding parameter value. So that is the motto. Okay, with respect to data science. Okay, before going to find out the inverse of the matrix, first let us see what is determinant of a matrix, how to calculate the determinant of a matrix. Okay, let's start with some simple example. Here I have taken a small matrix, 2 by 2 matrix A, which consists of the elements, the first row AB, the second row CD. How to calculate the determinant of this matrix? It's very simple. It's simple multiplication. So the determinant of a matrix A, that is det of A, is calculated similar by multiplying the corresponding column values, diagonal value, sorry. That is AD minus BC or CB, anything, right? Okay, so this is the way in which we can find out the determinant of any square matrix. Okay, so det of A is nothing but AD minus BC. Okay. Now let us consider how a determinant can be determined for a 3 by 3 matrix. For 2 by 2 matrix, it's very simple thing, but 3 by 3 matrix, you have to consider as more number of successive 2 by 2 matrix. That's all. So let us see here. It is a 3 by 3 matrix. A, B, C, first row of information, D, E, F, second row, G, H, I, the third row information. Okay, now I want to find the determinant of B. How to find the determinant of B? That is A. Let us consider A. So you have to leave the corresponding row and corresponding column of this element A of I comma, that is 1 comma 1. Okay. So the remaining values, this is a 2 by 2 square matrix. So it is A in A determinant of EF HI. I think it's clear. And next, minus B, there is a second element, right? Minus B, then leave the corresponding column and corresponding row. So the remaining values are D, E, and F, G. I have written like D, I, and F, G. Yes, plus. So now I want to calculate the corresponding values for C. That is, leave the corresponding column and its row. So I will get C into, right, DH, DH, and EG. So this is the formula by using which we can calculate a determinant of a 3 by 3 matrix, right? While doing, it's a scalar multiplication, you know how to do multiplication because I already explored here how to find the determinant of a 2 by 2 matrix. It's simple multiplication with corresponding scalar value A and determinant of this matrix with the scalar value B and determinant of this value with the scalar value C. That's all. So this is the case related to 3 by 3 matrix. Say if it is a higher order matrix, you have to apply the same procedure. See here, I have taken a 4 by 4 matrix. Then you have to consider 3 by 3, right? See, for example, for A, leave this one. So the corresponding 3 by 3 matrix. Minus B, leave this column and row. We will get E, G, H, I, K, L, and M, O, P. Similarly for C, plus C, leave that one. Then we will get E, F, H, I, J, L, and M, N, P. Yes, here it is. And similarly minus D, all right? So leave this corresponding row and column. The remaining things are E, F, G, I, J, K, M, N, O, S. So while computing all these things, so if you want to perform the determinant value of 3 by 3 matrix, again it has to be reduced to 2 by 2, right? And finally, we can find out the determinant of this 4 by 4 matrix. This is the way in which we can find the determinant of any M cross N matrix. But don't worry, Python and R, they are having their own library function for calculating all kind of these stuffs by calling a single library function. Okay, in order to find the inverse of a matrix, first we learned how to calculate the determinant of the matrix. Now the another task is given for us is we have to calculate the minor of a matrix. So the minor is very, very simple, dear participants. Let us take a square matrix. Yes, I have taken a square matrix, right, of size 3 cross 3. Now I am going to find out the minor for each element of the matrix A. That is the point to be noted. Okay, for each element means for each I comma jth element of the matrix A, I am going to find out the minor. That is, I have to that the resultant value should be a 3 by 3 matrix. Okay, see, now I am going to find out the minor of I comma j, that is 1 comma 1. What is the 1 comma 1 in this matrix A? It is 1. Now I want to find out the minor of the element 1 of the matrix A. Okay, it is very simple. Leave that particular corresponding row and column. Yes, I left. Then remaining values are 2, 5, 0, 2. Yes. Okay, we already know how to find out the determinant. Find out the determinant, that's all. That is 2 into 2, 4, minus 0 into 5, 0. So the answer is 4. So the minor of the element 1 of the matrix A is 4. That's all. Okay. Similarly, if you want to find out the minor of the element 2, what we have to do? Leave this column and this row. The remaining things are 4, 5, 1, 2. Do the determinants. That is 4 into 2, it is 8, minus 1 into 5 is 5. 8 minus 5, it is 3. So the minor of the term 2 is 3. So likewise, you have to compute the minor of the remaining elements 0, 4, 2, 5, 1, 0, 2, and you write it in by 3 by 3 matrix. Okay. So this is the way in which we can find out the minor of a matrix. Again, if you want to find the inverse of a matrix, the one more terminology you have to do is cofactor of a matrix. Now I am going to explain you how to find the cofactor of a matrix. If you want to find the cofactor of a matrix, first you have to find the minor terms and you have to check its sign. If the sign is even, add positive value. Positive when the sum of the indices are even, it turns to be positive. Otherwise, it's to be negative. I will explain with an example. Don't worry. I'm going to take the same example. Let us see. Here we find out the minor for the element 1, which is 2. So what is this indices? Indices are 1, 1. Now add the value of the indices 1 plus 1. So 1 plus 1 is 2. 2 is the even number. So the cofactor of this matrix A is, I have to assign only positive value, plus 4. So the cofactor matrix C, right, holds the value 4. That's all. See, the cofactor and minor matrix both are same. The sign is going to be differ. How the signs are differ? First go to the corresponding indices. If the indices, add the indices. If it is even, add positive sign. If the indices or adding the indices will give the odd number, then assign negative sign. That's all. See, one more time I will explain how I am going to get the value minus 3. Yes. So previously I calculated how to find the minor of this particular term 2, and I said that it is 3, right? By eliminating this column and this row, and 4 into 2, 8, minus 1 into 5, 5, that is 8 minus 5, that is 3. So that the minor is 3. Now cofactor. So cofactor, what I said, I have to check the indices. What is the indices value of 2? This is first row, second column, 1, 2. 1, 2, that is 1 plus 2. 1 plus 2 means it's 3. 3 is a odd number. So that I am going to assign a negative sign. So it comes minus 3. Okay. So in this way, I have to calculate the cofactor of all the elements of the given matrix. Okay. So if you want to find out the cofactor of a matrix, the idea is first you calculate the minor terms of all the elements and just do some kind of changing the sign depending upon adding the indices. While adding the indices, if it leads to even number, put positive sign. If it leads to odd, then assign negative sign. That's all. So in this way, you can easily find out the cofactor matrix of each element, right, of any given matrix. Once the cofactor is there, then the next step is to find out the adjoint matrix. See, in order to find the inverse, I am doing all this activity. So what is the procedure for finding out the adjoint of a matrix? First and foremost, when a given matrix is given A, you have to find the cofactor of a matrix. Then just transpose the cofactor matrix, which gives the adjoint matrix. That's all. The procedure is very simple to find adjoint of a matrix. Thus, calculate the cofactor of the matrix and just transpose this. Transpose, I already explained. just reversing the rows to columns and columns to rows. See here, in the previous example, I said for this matrix A, the cofactor matrix that we have calculated is 4 minus 3, 2, minus 4, 2, 2, 10, minus 5, 6. By using the minor, right? We determined all these things. Now, in order to find the adjoint matrix, just do transpose of this matrix C. Just transposing the matrix C, it leads to adjoint matrix. See here, 4 minus 4, 10. It be going to comes in a row. Yes, 4 minus 4, 10. Similarly, minus 3, 2, minus 5. This column is going to become a row. Similarly, minus 2, 2, minus 6. This column is going to be a row. Minus 2, 2, 6. Now, this is my adjoint matrix. Once the adjoint matrix is calculated for any given matrix, then it is very easy for us to determine the inverse of a matrix. Okay, then what is an idea behind to calculate the inverse of a matrix? Well, so if the adjoint matrix is given, just you have to multiply with the determinant of that matrix, right? You will find out the inverse. I will give some examples so that it will be very easy for you. Okay, let us see here. This is my A matrix, that is a given matrix. What is the first thing I have to do? I have to find the adjoint of A. Yes, the adjoint of the A is find out. Now, multiply the adjoint matrix by the inverse of the determinant of the matrix A. Then the resulting matrix is the inverse of A. See, let us see. What is the determinant value? We can easily find out. Here the determinant value is minus 2. I calculated the determinant value of the matrix is minus 2. So what I have to do, it's an inverse. Always inverse means what? 1 divided by determinant value, right? Okay, so 1 by minus 2 into this D, which will gives you the inverse of the matrix A. So this is the way in which you will find out the inverse of a matrix. Just find out the edge matrix, multiply the edge by the inverse of the determinant. Inverse of the determinant means 1 by determinant. That is inverse, right? Okay, 1 by determinant. Determinant value of the given matrix is minus 2. So I have put 1 divided by minus 2 into adjoint matrix. Okay, so this is my adjoint matrix. While multiplying these two things, we will find out the inverse of the matrix A. So this is the procedure is very, very simple. Once if you know the inverse of the matrix, then you can do wonderful things, right? I will show you through inverse how to solve a given big equation. I will explain you in the next slide. Let us see here. I am going to take the 3 equations. The 3 equations are x plus y plus z is my first equation. My second equation is 2x plus y equal to 1. It's my second equation. And my third equation is 5x plus 3y plus 2z equal to 4. It is my third equations. So in order to find the values of x, y, z, previously we solved this problem by using row echelon method, right? By applying a lot of computations. But now here I am going to use the concept of inverse, right? To find out the value of x, y, and z with a minimal number of steps. Let us see here. Okay. So this is my matrix A, that is my weights corresponding to the variables x, y, z, so that this representation can be represented by means of vectors, right? Say A is my given matrix and x is the corresponding variables, that is x, y, z will take the value of x, and z, it is my augmented values, that is 1, 1, 4. Yes, fine, good. Now what I am going to do, just by this equation, I am going to multiply both sides by A inverse, because the given A is known to me, right? So by following all these steps, whatever thing that I have explained to you, right? So by using all these things, first I will mathematically I will prove this one, right? How to find the corresponding values of x, y, and z, right? See here, in the vector notation, I am going to explain you. What I am going to do, just I am multiplying A inverse by both LHS and in the RHS. So A inverse AX into A inverse Z. Okay, fine. So now I am going to do some distributive law, right? Here comes the laws, right? For simplification purpose, right? So A inverse into A into X, that's a distributive law. So we people know that inverse into the corresponding element of this 1 by 7 into 7 always it leads to 1, you know. So that is the concept, right? So A inverse into A always leads to identical matrix. We know identical matrix is represented by I. So this computation becomes I into X. So the left hand side A inverse into Z. Okay, so the corresponding value of X, Y, Z is easily calculated by multiplying the right hand side value, that is an augmented values, that is 114, which is going to be multiplied with the A inverse of this given matrix. We can easily find out the corresponding values of X, Y, and Z. See how the computational costs are reduced to the core. That is the power of inverse, calculating the inverse, right? Now I am going to adapt the same concept in our data science problem to find out the parameter values. Let us see how I am going to solve this problem. Yes. So some participant asked, can you please correlate whatever may be the concept, mathematical concept that you have discussed with respect to data science perspective? That's why I think this slide will give you a very good picture. So now only I'm showing the data set. Let us see here. So in this slide, you people are seeing some data, right? No need to focus on the what is the logic of each feature. You have to know as a data scientist, but now consider here is some data is given to you. So here the bold letters, right? This is called features. Some authors refers variables. Okay, so otherwise they will call column values. Okay, and these are all the row informations, okay. So I'm saying this row is called an equation. This row is called one equation. Equation number 2, equation number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 equations are there with variables 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 variables or features are there, right? With respect to, I have to solve these 14 equations having this kind of variables. That's all. For that, each variable has its own, I have to learn the parameter for each variable, right? Here I am going to consider only subset of features. That is a very, very important thing in data science. Selection, feature selection, right? So even though a data set is there and it consists of more number of features, right? With an expert, with a domain expert, we have to identify which features are needed for our analysis. That feature alone to be taken and you have to consider for computation, right? It is not necessary to take all the features, because if you are going to take all the features and if you are going to do the analytics part, I think the accuracy may be reduced, right? So in this way, it is always necessary to have a domain expert, right? With I am speaking everything with respect to real-time projects. Okay, fine. So here my matrix is get formed. See, I have taken the matrix X. See, while seeing X, you are seeing some values. So these are all the features I am taking: RS, RA, W, OBP, SLG, and BA. So these are all the 6 features that I have considered, right? And its corresponding values are taken, right? So if you see, it's a matrix value, right? I think 14 rows are there and 6 columns are there. So it is a 14 by 6. This is my size of order of the matrix, my data set. Now what I am going to do, I have to find, right, the parameter for each features. with respect to all the 14 instances, I can say like that. All right, that is my job of any data science people. All right, but now I am expressing everything through mathematically. Okay, yes. So this is ultimately we are going to do to find the final parameter vector theta, right? So that is the corresponding value, right? Weight with respect to all these features, right? Okay, that is my theta. So initially, this particular data set is characterized by 6 features, that is x1, x2, x3, x4, x5 and x6. Each is going to have its own corresponding theta value, right? So I am going to formulate for simplicity in terms of linear regression formulation. That is my dependent variable. Let us consider it is a y. Okay, see. So in this example, y equal to, so I said that there are 6 variables are there. So I am going to take w0, it is my initial constant value. So for the first feature, it would be w1 and its corresponding feature is x1. I'm going to write a linear regression, okay, multivariant, right? Okay, so next I have to find out the another parameter w2 for the for the variable for the feature x2. Similarly, for the feature x3, I have to find out the coefficient w3, right? Up to I have to find out, because 6 feature I said, so x6, sorry, for my writing, okay, it is w6. So these are all the parameters I have to find out. So this parameter can be easily found by using the concept of inverse. So that is the thing I want to explain right now. Okay, so for each independent variables, that is for each features independent variables, I have to calculate the parameters, right? I previously explained how I solved this problem by using this vector for each variable. Here this equation consists of what? 3 variables only, x, y and z. Now this problem instant, which consists of 6 variables. Let us consider x1, x2, x3, x4, x5, x6, right? And corresponding matrix values. This is my matrix value. This is my w. Okay. Now you have to take, this is my dependent value. Okay. So in this way, we can easily solve any data science problem. Okay. By using the concept of inverse. Okay. Now I am moving to another major important mathematical concept in linear algebra is eigenvalues and eigenvectors. See, I think most of you, I think in your FDP also, whether I don't know whether you are coming up with a principal component analysis, right? Where the eigenvalues and eigenvectors plays a very, very vital role, which is mainly used for dimensionality reduction. Say for example, you are having a data set that is a high dimensional data set. I already told that when a data set is said to be called as a high dimensional, when there are more features compared to its instances. Okay, see, this is a classical data. So what is the data set that I have shown to you is a classical data, because number of attributes, number of features is less than the number of instances, right? So it's a classical data. When the number of features are more compared to that of the instance, then this data is going to be called as a high dimensional data. When both the features and the instances are going to be approximately equal to infinity, then we will say the data is that is a big data, right? It's a big data problem. Okay, fine. So automatically, if you are going to have a very large number of features in our data sets, it's not, I already told that it's not necessary to take all the features. So there will be some redundant feature. We have to remove that one. Otherwise, I have to say we have to select in such a way the feature which is more important for our analysis. Okay, that can be done by using the concept of eigenvectors and eigenvalues. Now I am going to explain you by taking some a simple mathematical problem, how to find out eigenvalues and eigenvector for a given problem. So that is my goal. So before that, this is the initial representation of eigenvalues and eigenvectors. See here, so that is A dot V equal to lambda dot V. Don't worry, here A is my matrix, that is my data set, right? It's an n by n matrix, okay? And V is a non-zero n by 1 vector. That is, I already explained what is a vector. It's a column vector, right? It is a non-zero. That is very, very important. If it is zero, then it is not possible, right, to do computation, right? Surely that V must be what? It's a one-dimensional vector, and lambda is my scalar value. I have to find out. In next slide, I will show you how to find out that lambda, that is my eigenvalue, and V, that is my eigenvector with respect to the data set A. The data set here is my matrix, okay, given matrix. So this is the representation, right? A data set will be given to you, and what you are going to do, you are going to find out the eigenvectors, which is in the left hand side, and similarly the eigenvector should be multiplied by eigenvalue, that is lambda, and I have to find the lambda. I will explain you how to find out lambda and how to find out the values of the vectors also, right, by taking some raw examples. Okay, fine. Now the same problem, this given problem, A dot V equal to lambda dot V, I am going to rewritten in some way so that for simplicity purpose. See here, I have moved the right hand side to the left hand side. That is a simple thing I have done. I have not did any complex mathematics or mathematical operation, right? Simple thing. I moved the right hand side to the left hand side. Okay, it comes A dot V minus lambda V equal to 0. Now again, I am going to multiply with identity matrix I. So nothing will be get changed, you know. So 2 into 1, the result is 2 only. Similarly, like that, I multiplied the identity matrix with the vector V. Okay, nothing is changed. Okay, fine. So no change with respect to LHS. Now I am going to do some distributive law, right? So I am just doing some rearrangements. That is A minus lambda into I am taking V outside. That's all. Simple thing, right? Some distributiveness, I put it over here. Okay. So I already mentioned that V should not be 0. Okay, fine. So this equation will have solution. That is, this, while solving this particular thing, it will lead to some characteristic equation. So this, once it is a characteristic equation, you can easily find out the roots. The roots are called as lambda, right? That is eigenvalues. With this lambda, I will find out the value of the corresponding vector. So this is the formulation for finding out the eigenvalue and eigenvector with respect to the matrix A. Don't worry, I will explain everything with a running example. See here, I have taken a data set. So for a big data set, it is not possible for me. So that I have taken a very, very, very small data set. Sorry, it's not a data set, it's a matrix. I can say it's a matrix mathematically. But as a data science people, always you think about, this is my data set, given data set. Okay. With this data set, how I am going to find out eigenvalues and eigenvectors? That is my objective. Okay, see here. So now I know the formulation. The formulation of my problem is like this. A dot V minus lambda into V equal to 0. All right. Okay. So before that, the general notation is here it comes A dot V, right? A dot V minus lambda V. Okay, I will take that one. So A minus lambda into I, right, equal to 0. Okay, I have to find out this value. Okay, V, fine. So A minus lambda into I equal to 0. I have to find the value of A. Okay, so what is my matrix? A is my matrix. 0, 1, minus 2, minus 3. Minus lambda into I. What is my I? It's a 2 by 2 matrix. A is 2 by 2, you know. Similarly, my I is also 1, 0, 1, 0, 1, 0. By multiplying with minus lambda, it becomes minus. Okay, I'm multiplying. So lambda, instead of identity matrix 1, 1 here, it is multiplied by lambda, so that I am getting lambda 0, 0, lambda, which is equal to 0. Now what I am going to do? just I'm going to do matrix subtraction. That is 0 minus lambda, that is minus lambda. 1 minus 0, that is 1. Minus 2 minus 0, it is minus 2 only. Minus 3 minus lambda. Okay, fine. So now this is my my given matrix. Now I have to find out the determinant values, right? Just by multiplying, right? So that is minus lambda into minus 3 lambda into minus lambda, right? So minus into minus plus lambda into 3, that is 3 lambda, and minus into minus plus lambda into lambda, lambda square. So lambda square plus 3 lambda, and minus 2 into 1, 1. By taking a negative, it becomes positive, right? Okay, so this is my characteristic equation. I said that, you know, the characteristic equation. I find out the characteristics equation. So lambda square plus 3 lambda plus 2 equal to 0. Now I have to find out, this is a quadratic equation. I have to find the roots of this particular equation. It is very easy to find the roots of the equation. That is lambda is, I have to, so simple mathematics, that is I have to get 2 in product wise, in some wise I have to get 3. So automatically the roots are, that is lambda, it's a quadratic, you know, I will get 2 roots, right? My lambda 1 is minus 1 and my lambda 2 is minus 2. See here, multiplying minus 1 into minus 2, I will get 2. Adding minus 1 and minus 2, I will get plus 3. Okay, so just for verification, I'm saying all these things. I think you come across with this all this mathematics in 9th standard, right? Okay, now I find out the values of lambdas. That is my eigenvalues. Now I am going to substitute the corresponding lambda 1 into this equation, and I am going to find out these corresponding vectors, right? That is my objective. See here, a dot v1 equal to lambda 1 into v1, right? So that is my formulation, right? So here I am just moving the right hand side to the left hand side. That is a minus lambda 1 and taking v1 common, that is distributive law, right, which is equal to 0. So I know the value of the matrix A, right? Now I am going to do subtraction. So it is 0 minus lambda 1, it is lambda 1. And next is 1. Similarly, minus 2 minus lambda, sorry, I'm going. So that is a minus lambda 1 into v1 equal to 0. So where is my a? Here is my a, that is 0, 1, minus 2, minus 3, right? I'm going to do it only with diagonal things. Okay, it is minus lambda and minus 3 minus lambda, right, into v1. So ultimately I'm getting I have to find out the eigenvectors v1. That is my objective. Okay, fine. So now I know the value of lambda 1. What is my lambda 1? My lambda 1 is minus 1. So substituting here, minus 1 minus, it becomes 1. So 1, 1, minus 2, again minus 1, right? It is minus 1, it becomes minus 2, minus 3 plus 1, it becomes minus 2. So this is the corresponding value, and its corresponding vector we have to find out, you know, v1. Okay, here I am going to take this 2 rows of information is there. So I am going to consider v1 comma 1 and v1 comma 2. So this is the way in which I am splitting the vectors, right? I am splitting the vectors. So I have to find out only v1, right? So the corresponding values are v1 equal to, that is v1 comma 1, and next is multiplication. Multiplication is just a multiplication. 1 into v1 comma 1, it is v1 comma 1 plus, and 1 into v1 comma 2, which is equal to 0. So we can find out v1 comma 1 equal to minus v1 comma 2. So what we are doing here, we are going to find out the vector and we are going to determine the column vector. Here the column vector, one is positive, another one is negative. That is the point to be noted, right? For the corresponding value of lambda 1, we are having one vector. Similarly, we have to find out for the corresponding eigenvalues, we have to find out the corresponding eigenvector in this similar fashion, right? So these eigenvalues and eigenvectors are mostly useful for finding out which features are more influence in your problem. So that is the purpose of finding out all these kind of mathematics, that is eigenvalues and eigenvectors. Okay. now I am slowly moving to, so that's all about linear algebra, right? So now I am going to touch upon statistics. Okay, so this slide I got it from one book, right? So it's a very nice interpretation, so that it attracted me very much, so that I have put it here. So there are three kinds of lies, right? Normal lies, damned lies, and B. Bisrael said that it's a statistics, right? So he said statistics also is a one type of lie, but don't believe that, right? I don't know why he said. Okay, just for fun, I am put this particular slide. Okay, why study statistics? Again, data is everywhere. So whenever there is a data, with the help of statistics, you can do wonders, right? You can give a proper decision to the decision maker, right? So that is the purpose we are studying
Kumara,
statistics. Yes, sir.
some message is there. Somebody asking me explain the previous slide once more. Something.
Which slide, sir?
Previous slide they are asking. Maybe last slide of linear algebra.
Oh, okay, okay, sir.
Shailaja Josh, you can ask if you have any doubt.
Madam, any doubt? If you can unmute yourself and you can ask me. Whether here, in eigenvalues, eigenvectors?
Oh, she has a problem with mic, I think.
Okay, okay, okay. Sir, after the entire session, entire slides are get over, I will come to this point again, sir.
Okay,
Okay,
sir.
okay.
Sir, can I ask one question at this point?
Yes, please go ahead, sir.
Actually, sir, in this case, for finding out the eigenvectors, you said that the data set is a square matrix, right? In crossing.
Yes, yes, yes.
But in real life situation, it may not be possible, right?
That's why you can go for single value decomposition. Have you heard about this concept?
Yeah, I have heard.
So once a data set is given to you, so you can decompose the data. Do you understand, dear? So once if you are going to decompose it, you can split, you can do some kind of segmentation over the data set. Okay. While doing such kind of decomposition, you can find out the square matrix. Do you understand?
Okay.
Then you
Thank
can do some computation.
Yeah.
So decomposition plays a very important role, right? Okay.
Right.
And at the same time, negative factorization. These are all the higher end mathematics are there. Okay.
Right. Thank you, sir.
If time permits, surely I will explain all these things to you.
Okay. Thank you.
Okay. I am coming with statistics. For another 30 minutes, I am going to discuss about only statistics, and surely you will enjoy, right? That is damn sure. Okay. So no matter what about the application domain, you can do some statistics. For that, I am going to narrate some simple mathematics. We have our group members solved that one. So I think everyone, we are proud of getting gold medal in Olympics, So that Neeraj, right? So we did some kind of how Neeraj achieved this particular thing. Are you able to see my screen?
Yes, sir.
So whether are you able to see my screen? Okay.
Yes, sir, you can see, but if the font size is a bit bigger, so if you press Control plus.
Okay. It's an image.
Control plus. Yes. Now it's coming.
Now is it clear? So this is the actual javelin throw, right? Did by our gold man Neeraj Chopra, right? Okay. So automatically it's pure mathematics, right? We have to find the angle. That's all. When the angle is good while throwing his javelin, then automatically he is going to throw a very long distance. So ultimately we have to find out the range of projectile. That's all. That is an R. So the general formula for find out the range, right? That the distance, right? It is u square sine 2 theta divided by g, where u is my initial velocity. I think you people, this is something related to physics, and g is my gravitational force with respect to the javelin, and theta, that is it plays a very vital role in what angle his arm is moving, right? So ultimately we know that he achieved 87.58, right? That is the distance covered by the gentleman. So usually the theta should be 45, right? If it is between 40 to 45, so we can achieve the greater range. That is the statistics. That is the model says like that, right? while doing this calculation with this formula, so with the initial velocity of 29.3 meter per seconds, and with the gravitational force, normally it's a constant value, is 9.8. So he achieved this particular thing, 87.58. See, even in any kind of sports, everywhere there is mathematics, right? So we can enhance the skill of a professional through by means of these equations only, right? Okay, but yes, for curiosity purpose only, I have showed this particular thing. So here I'm having n number of applications where you can build a mathematical model for that. Okay, is it okay? Is it okay, Kumar sir? Can I proceed?
Yes, 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 sir.
Okay,
Yes, sir.
okay.
Yes, sir. Proceed.
Okay. So now I'm coming to statistics. So what about statistics? It's a science, I can say like that. What we are going to do, I'm going to collect some data, I'm going to organize some data and present the data in terms of some visual representation, and finally I'm going to analyze the data, and after analyzing I have to interpret the data for what? For making effective decision. So that is all about statistics. Data collection, some instruments are there. How to organize the data, some procedures are there. How to present the data, some visual representations are there. How to analyze the data, some models are there. And how to interpret this data, some models are there, right? So I think I can touch all these things, right? Don't worry. So you can find statistics everywhere, right? Say for example, with respect to weather forecasting, it's a statistics, right? And either it may be a social science researcher. So with the help of the statistics only, he will do all these kind of computation, right? Especially in insurance industry, especially the financial market, with respect to medical field, with respect to winning the election or not, wherever you take any application, by doing some kind of statistics, we can predict, right, the outcome. But don't believe that all the outcomes leads to positiveness, right? There may be some kind of false also there, right? But it should be acceptable. Okay, fine. Now, if you want to do some kind of statistics, you have to know certain basic things. I'm going to focus that thing first. And the first and foremost is the variable. So in statistics, variable means column, that is attribute. So previously in our data set, we will say attributes, that attributes here it is called as variable. And data are the values, that is the observation. I said that, rows of information, that thing they will call as a data. Okay, so the collection of data values, that is called data set. So ultimately we will have variables and corresponding we will have data, and all together, right, the entire instances with the features, I will call it as a data set. Okay. And there are actually two types of statistics are there. One is descriptive statistics and another one is inferential statistics. Mostly the people accept only inferential statistics, right? I will explain you very soon what is inferential statistics. Descriptive statistics means I'm going to take the entire population and I'm going to do some computation. Then it is called descriptive statistics. A common example for descriptive statistics is survey. Say for example, if any people going to do some survey, they will consider all the population. They never leave any particular sample point, right? They will take all the sample points and they will do some computation. That kind of thing is called descriptive statistics. But in our field of interest in data science, we never bother about descriptive statistics. We only focus on inferential statistics. So inferential statistics means, so the population will be there, entire population will be there, but we are not going to do the computation with all the elements, all the objects in the populations. But what we are going to do, we are going to take some sample, some portion of objects that I am going to take, and I am going to do some computation. And after the result I got, I will generalize to that particular population. That type of statistics is called inferential statistics. That is, from the population, I'm going to take some sample and I'm going to do some computations. And if I got some result, and I will generalize to the population. That kind of study is called inferential statistics. I think this picture will give you some more idea. So if I'm going to take all the sample points in the population, it is descriptive. So if I'm going to take selectively, right, some points, with this some points, I'm going to build a model and I'm going to do the analysis and I'm going to generalize with this population, then it is called inferential statistics. Okay, so once again, so here there are n number of costs are there. If I want to do some the analytics over all the cost information, it's not necessary to take all this cost information. I'm going to take some samples. With these samples, I'm going to do some computations and I'm going to generalize to the entire population. Again, it is a inferential statistics. Okay. So there are how to take a sample. That is a very, very important thing. See, from the population, selecting the sample is very, very important. So there are several ways in which you can select the sample from the population. The most important thing is simple random sample. That means each sample has the equal chance of being selected. So there should not be any kind of priority in the population, right? All the samples to be given an equal priority. That kind of technique is called simple random sampling. So next is stratified sample. That means I'm going to divide the population into groups, otherwise called as strata. So once the strata is formed, then I take a sample from each stratum. That is called stratified sample. Say for example, see here there are group of peoples are there. So I divided the group of peoples into some stratum. See, this is stratum number 1, 2, 3, 4. 4 strata I found. From each stratum, I'm going to select some sample points. Say from this strata, I'm going to take 2 sample. From second strata, I'm going to take 1. So from third, 2, and from fourth, 2. This is called stratified sample. So the third technique is cluster sample. That means in a population, I'm going to divide into again strata, right? So divide the population into strata, then randomly select some strata. That is the thing. See, any one of the strata is going to be selected, right, for analysis. That kind of activity is called cluster sampling. Okay. Instead of taking each sample from each strata that is stratified, I am going to divide the population into strata and I am going to take any one of the strata from the analysis. That is called cluster sample. And systematic sample, that is randomly selecting. Say for example, this is a population. So every 5th sample I am going to take from this population. That is called systematic sample. Say 1, 2, 3, 4, 5. I am going to take 1, 5, next 10, next 15, next 20. Like that, if I am going to move and I am going to pick the points, then it is called systematic sampling. Okay. So these are all the 4 ways in which you can select the samples from the given population, right? So if it is a social science research, right, the first question they will ask you is what kind of sampling you have applied. Okay, that is very, very important. Even if you are going to generate your data set, dear participant, I am once again saying you can do data analytics over secondary data or you can do data analytics over primary data. So the science discipline, in our science discipline, usually the research community accept only secondary data only, because there will be some benchmark data set will be available. From the benchmark data set, you have to develop some model and you have to experiment it and you have to show the accuracy. Then only the community will accept. But regarding social science, apart from secondary data set, they will create their own data set. That is a primary data. Through by means of questionnaires, they will select the data, right? But there are certain application in our scientific field, also in computer science also, there is a necessity to create a primary data. So while doing such kind of a primary data collection, I think at that time you have to be very strong in what kind of sampling methods you are going to apply. That is the purpose I explained all these things. Now I am talking about Now I am talking about particular part. Collecting, right? So while collecting this information, you have to do all these kind of stuffs. I think I already explained all these things. So now I'm coming to variables, because variables plays a very, very vital role in statistical analysis. So the variables can be classified under two categories. Either the variable may be a qualitative variable, or either it may be a quantitative variable. If you see any data set, you will have these two kinds of variables only. Otherwise, I can say categorical variable or continuous variable. Some authors can say like that, right? Okay. But usually the social science researcher call as qualitative and quantitative. The computer science people, we people call the variables either it may be a categorical nature or it continuous nature. Let us see here. See there, you always, if you there is a data set, you come across with the feature called or a variable called gender. So the gender is always a qualitative variable, that is, or categorical variable, that is a gender will holds the values male, female, or transgender, three values possibly, right? We can fix it as a category, right? Okay, that is the meaning of qualitative variable. Then what is quantitative variable? The same thing I am going to take. So any variable which having numerical values, right? Numerical values, then I can say it is a quantitative variables. Once there is a numerical values are there, then you can do some kind of an ordering, or you can do some kind of ranking. Okay, to which variable? To the quantitative variables. Say for example, the variable age is a numerical, and at the same time we can rank or the peoples with respect to age. At the same time, the heights, weights, and body temperature, all are the examples of qualitative variables, right? So if you are going to see any data set, you are going to see these two kinds of variables. Either it may be qualitative in nature or it may be quantitative in nature. Just for fun, I put this particular slide. I don't know how to do statistics. Don't worry. If you don't have data, then it is not possible for you to do any kind of statistics. Once if you have a right data and enough amount of data, then only it is possible to apply data science. That is the purpose that I have put this particular slide. Okay. So first part in statistics, I explained you how to collect the data. That's all. So next most important thing is how to organize the data, right? So that is the thing I am going to focus right now. See here, you are having some data. You are having some pool of data, right? Obviously, you will say this data is in terms of quantitative in nature. That is a continuous data. It's a numeric data, right? Can anyone tell how many data are here? Any participant?
50, sir. So 50.
Absolutely. Here is the answer, my dear. Right? Okay. Total is 50. So here I am having 50. So 50 data are there. Now I have to organize it, because organizing the data itself is a very, very important task. Right? See how to organize. For that only, there is a concept called as frequency distribution. So through frequency distribution, you can easily organize the data. Right? See here. Whenever there are some problems in a classical data science problems, you are come with continuous values. It is necessary to convert to categorical in nature, right? Okay, I will explain you all these things later. Okay, because the flow will be get disturbed. Okay, first I will explain what is frequency distribution and how to do frequency distributions through by means of the concepts called class limits. See here, from this raw data, surely you will find some lower value, right? Here the lower value is 35 and the higher value is 90, right? Okay, so just by finding the function minimum value, min function, and max function, you can find out these particular things, right? So with these stuffs, I can easily find out the limits. That is a range I have to fix. So here randomly I have chosen the range is 6. So 35 to 41, it is my class 1, and 42 to 48, because I range I fixed is 6. So while doing this kind of things, I come across with how many class labels? 1, 2, 3, 4, 5, 6, 7, 8. See here how beautifully I am going to this. All this data is going to be fit into this particular labels. How many labels? 8 labels. How to do? Yes. Once the data is given with the help of a minimum value and maximum value with the help of range, I fix the limits. I fix the class limits. Then you have to process each data. Take the first data 49. Where it fits? It fits here. Sorry, here 42 to 41. So put one tally, right? So the entire result I have pasted here. But initially you have to do like this. Take one data and check the limits and put the stick symbol, right, and count its frequency and do the tally. And after exhausting all these values, once the tallies are over, then count the number of sticks in these tallies. That is 3. Put the frequency 3, right? 4. Similarly, 10, 10, 5, 10, 5. Okay. So ultimately 50 for a simple check. Okay. So this is called frequency distribution. So through this frequency distribution, I can organize the data through by means of class limits, right? So this can be done using statistics. Once we are having a handful of data is given to us, we can do this kind of an activity, right? Now I am going to explain you how to do this frequency distribution, that is assigning classes to each data values through these two techniques, that is categorical frequency distribution and grouped frequency distribution. By using these two particular concepts, I am going to explain everything. Okay. Yes. First, I will explain you how to do categorical frequency distribution. See here, you are seeing not a continuous value. In previous example, you seen continuous values, that is quantitative data. But here I am given with qualitative data, that is the data are in categorical nature. So if you see it in depth, I think it's a blood group, right? A, B, O, like that. Okay, it's all blood group. Now how I am going to organize this categorical frequency? Here I am not able to do minimum value, maximum value like that. It's not possible for me, and it's not possible for me to fix the range also. Just count how many categories are there. So category A is there, class A is there, B is there, O is there, AB is there. So that much of class is there. Similarly, you have to use the same logic tally. If you take A, put one tick mark. So next B, in B put one tick mark. Next B, another tick mark. AB, so go and put one tick mark. O, put one tick mark. So and do it for all these datas, right? Once this tally is over, we can easily find out the frequency distribution. 5, it is 7, 9 and 4. Ultimately 25. This is my 25 data points are there. Here I calculated percentage. So in this 25, so the class A 20% of data are A, 28% of data are B, and 36% of data are belongs to class O, and 16% of data belongs to the class B. See, easily we can do some categorical distribution. Let us consider grouped frequency distribution. The grouped frequency distribution works good only for numerical values, right? Now here, previously I assumed everything. Here I assumed everything I did, right? Minimum value, maximum value. So the range, randomly I have chosen, but there is some procedure. There is some algorithms are there. So this is the algorithm, right? How to determine the class, right? For any given data. Okay. So what first we have to do, once the data is given to you, and how you are going to organize it, how to determine the class limits, right? It is very simple. Find the highest value and the lowest value. That is my first step. So from the data set, the highest value is 134. Where is it? Here it is, 134. And similarly, the lowest value is 100, right? Lowest value is 100. Somewhere is here, right? So then you have to find out the range. Easily you have to find out the range by subtracting highest value minus lowest value. That is 134 minus 100. That is 34. So 34 is my range. Now how to determine the number of classes? How to determine this number of classes? You have to divide the range with some specific numbers, right? It's a thumb rule you have to apply. Select the number of classes, right? Usually in any statistical approach, they will go with the number of classes between 5 to 20, right? So this is an optimal value. There is no thumb rule for that. You can choose anything. According to that, the interpretation may differ. So here I am going to choose the value 7. So 7 classes to be there. Okay. Now the width is calculated by range, that is 34, and I chosen the number of classes as 7. So 7, it is becomes 4.9. So the intervals is becomes 5, approximately 5. So that I am taking initial value is 100. 5, that is 100, 101, 2, 3, and 4. Yes. 100 to 104. Similarly, 105 to 109. So I divided up to 134. But the boundaries are not fixed. They are discontinuous. So in order to maintain the continuous nature, I have to find the class boundary. How it is? It is easily done by subtracting the lower limit with 0.5 and incrementing with the upper limit by 0.5. That can be done. Continuous thing. That is 99.5 to 104.5. And continuously I am going to monitor. That is 104.5 to 109.5. Similarly for all these cases up to 134.5. Even though there is 134.5 is not there, but this is the way in which you have to find out the class boundary. Once the class boundaries are there, then normally the same procedure you have to adapt. Take the first data value and check in which boundary it happens, then put the tally symbol. So like this, explore for all this data. Once this phase is over, then calculate the frequencies, right? The sum of the frequency must be 50 for cross-checking. Okay, that's all. So this is the way in which you can organize the data. So once if you are going for a primary data collection, say for your application, so after collecting the data, you can organize the data like this by using frequency distribution, by using this algorithm. So this is the general algorithm for calculating the grouped frequency distribution. Yes. Now, the third thing is, I said that visualization, right? How you are going to present, right? So if I said you have to present the data through some by means of graphs, right? So by using Python and R, they are having n number of graphs out there, but it is not necessary for your particular application. You have to choose the corresponding graph. Okay, that is a very, very important thing. So histogram is a one type of graph you can use only for frequency distribution. If you want to show the frequency distribution of your data, then the appropriate visual representation is what? A histogram, right? See here. So these are my class boundaries, right? Now I have to represent this data pictorially, right? See here, and say for example, these class boundaries represent the temperature, and these are all my frequencies, right? I have to see what is the highest temperature recorded. See, from this beautiful histogram, you can easily interpret the results, right? See here, 99.5 to 105. What is the frequency? 2. So 2. See, 104.5 to 109.58. So I have put 8, the vertical bars. So I think the interpretation becomes very easy. Instead of class boundaries and frequencies are given, so little bit the interpretation is tough. But once if you shown by means of this kind of diagrams, interpretation becomes very easy. Okay. So the another interpretation is frequency polygon. I think most of you know histograms. I think most of you don't know the concept of frequency polygon. So frequency polygon means you have to find out the midpoints of the boundaries. That's all. It's very simple in nature. See, what is the midpoint? 99.5, 104.5. Just add these two things and divide it by 2. That gives the midpoint, 102. That's all. But no change in the frequency. Its frequency is 2 only. Okay. So I am going to calculate the midpoints of the class boundaries. Now I am going to point only the midpoints value. See here, 102. So this is in the y-axis frequency, x-axis temperature, and the graph represents the frequency polygon. That is the midpoint values. 102 and 107 and 112, 170. Okay. So in this way, you can represent the data, right? So the another representation is ogive. So ogive is a graphical representation of cumulative frequency, right? So cumulative means here it is not cumulative, right? But here the data are in cumulative nature. less than 99.5. So from 99.5 to 104.5, from 99.5 to 109. So this is a cumulative frequency. This is not cumulative frequency. Okay. So if you want to represent the cumulative frequency, then ague is a very nice representation for you, right? See here again, x-axis is the temperature, y-axis the frequency, and I am going to represent only the cumulative nature. See, 99, this thing is become 0. So 104.5, 104.5, the value is 2. So approximately 2, exactly 2, sorry. So this is the ague representation of a given data. So I covered 3 things, that is how to first collect the data, and how to organize the data, and third one is how to represent the data. Okay. So once if you did all these things, then by taking these machine learning algorithms and by using the deep learning algorithms, you can analyze and you can interpret. That is a thing. I think in the remaining session of this FDP, you are going to come up with the supervised learning algorithms, unsupervised learning algorithms, and possibly I think deep learning also. With these things, you can do some analytics, right? So with these statistics, I covered these 3 concepts. So even whatever may be the machine learning or deep learning models you are going to discuss, surely the mathematics will be there. Say, for example, if you are going to do a Navy-based algorithm, conditional probability comes under picture. That's why I am right now going to focus on probability theory, right? That is Navy-based conditional probability. P of A by B equal to P of A intersection B divided by P of B, right? So if you want to know all these stuffs, you have to know little bit of probabilities. So that probability that I'm going to touch upon for another 10 minutes only, my dear. So what is probability? It's a chance, I can say like that. A probability is a numerical measure of likelihood of whether an event occur or not, right? It's a chance only. That is probability. Usually the probability values lies between 0 to 1, right? 0 to 1, just like a number line, right? The probability near to 0 indicates that event never occur, right? Say for example, in my town, it's very good. I'm getting very good sunshine. Therefore, the probability of rain is 0. I can say like that, right? Okay. The probability near 1 indicates that event is almost certain to occur. Now the time is 3:40. So around 4 p.m. surely I am going to stop my lecture. Yes, probability is 1, right? You will never allow me to continue for 5 p.m. So I am just kidding, dear participants. Okay, fine. Probability as a numerical measure, I already told that, right? It lies between 0 to 1. If it is 0, the event is very unlikely to occur. If it is 0.5, that is chance in both sides. If it is near to 1, you can say that the event is almost certain to occur. Okay. Next, I am coming to discuss about what is an experiment. See, with respect to statistics, the experiment is different. And with respect to physics and chemistry, the experiment is different. In statistics, the notion of an experiment differs right with the other physical science. Okay, I already told that. In statistical experiment, the probability determines the outcomes. That is the outcome of an experiment. That is matter in statistics, right? Even though the experiment is repeated continuously or different times, you can't expect the outcome should be same. That is the beauty. That's why the experiment here in statistics is called as random experiment. You can't predict the exact outcome. Okay, so here in statistics we will say only random experiment. And next is sample space. Sample space, before that, outcomes. When you are going to do some kind of an experiment, and what are all the possible outcomes are there? Right? Okay. So if there are more number of outcomes, and each outcomes are called as sample point. Okay. See, now I am going to show some experiments to you. So these are all the experiment. Tossing a coin, inspect a part of inspection of a particular part, conduct a sales call, roll a die, play a football game. Right? These are all the experiments I can say. And surely, what are all these sample space? So tossing a coin, obviously the outcomes are head and tail. Inspection of the part, either it may be defective or non-defective, right? Conduct a sales call. Either he is going to purchase or no purchase. Rolling a die 1 to 6. Play a football, win, lose, or tie. So these are all the outcomes, right? I can say it's all the labels. I can say slowly you can move to supervised learning, right? Right. So the probability of event always, I said that it should be lies between 0 to 1. And if you are going to do the experimentation several times, and P of EI, that is P of 1, P of 1, P of E1, P of E2, P of E3, if you're going to sum everything, always it must be equal to what? 1. That is the basic requirement of assigning probabilities to the events. So sum of the probability of all the experiment outcome must be equal to 1. It should not more than 1, or it should not less than 0. Right? That please take it to the core. And again, there are some beautiful laws out there, similar to that of set theory. The probabilities in statistics also we are having laws. Some addition law is there, multiplication law is there, right? Independent law is there. So the same thing, and A and B, there are 2 experiments. Here it's not 2 sets, 2 experiments happened, right, simultaneously. Then it can be represented as P of A union B equal to P of A. That is probability of occurrence of A plus P of B minus P of A intersection B. Here the events can occur individually, or the event can occur in the same time. This is addition law. But if the events are mutually exclusive, then slightly we have to modify that rule. That is P of A union B equal to P of A plus P of B alone. Okay. Surely in this case, P of A intersection B becomes 0. So my answer is P of A union B equal to P of A plus P of B. And conditional probability. If you clearly understand conditional probability, you can solve 80% of computer science problem. So all I can say like that. I can say like that. Because our life is purely conditional probability. Our data, you take any data science problem, again it is a conditional probability. Because one feature depends upon the other feature. We have to determine, right? I can say like that, right? It may be wrong or right. Okay. So the conditional probability, it is represented in P of A by B. And the general formula is P of A intersection B divided by P of B. That is the formula. I have not written the formula, but this is the one. So I touched only very basic things related to probability, right? So if you are going to study many supervised learning algorithms like decision tree algorithm, you come across with entropy, there comes probability. If you are going to discuss with respect to Navy based algorithm in machine learning, there comes conditional probability. If you are going to discuss about support vector machine, then it will comes marginal fitting, right? If you are going to choose random forest, again it's a decision tree, entropy, right? So whatever model you are going to explore, surely you will touch upon with some probability and mathematics.
Ba.
I am getting some kind of noise. I request the participant, you just give me 15 minutes of
इधर
time.
mana balu. इधर ओके बाकी लाने इधर ही.
Kumar sir?
Hello, Aisha Farsina, please mute your mic.
यार उन बात से.
Aisha Farsina. Yeah. Our student only, na? Manas?
Can I proceed, sir?
No, sir, I don't know.
Okay.
Sir, I have a doubt, sir.
Madam, just give me 5 minutes of time. I will finish the chi-square test, so it will give a very good understanding. Okay. Then surely I will answer your question. Okay. Can I proceed, Kumar sir?
Sir, 1 more minute. Okay. Okay, continue, sir.
Okay, sir. I will first clarify the doubt, sir.
Okay, sir. Okay.
Yes, please. Any doubt?
No, sir, continue.
Okay, fine.
Yes, sir, I have a doubt, sir. Hello, sir.
Yes.
Yeah, this chi-square test, how to select the like hypothesis, sir? Like if the
Madam, that's why I am going to explain right now the chi-square test, madam. Okay.
Okay, sir. Okay.
Madam, if you give me 10 more minutes, I will clarify everything. Okay. Madam,
Yes, sir.
your audio is very feasible, madam. I am not able to hear anything. Kumar sir, if you are
Yes,
able
sir,
to hear,
sir.
Okay,
Sir,
fine.
you continue, sir.
Okay,
Last
okay, thank
5
you.
minutes will give time.
Okay, okay, sir. Okay, thank you. Dear participant, now I am going to explain you one particular concept called how to find out the association or relationship between the variables. Otherwise, I can say how one feature plays an influence over the other feature. So usually we will take it in terms of framing the hypothesis for our research work. So if you want to test our hypothesis, there are a lot of techniques out there. Now here I am going to use chi-square test for the given data set, and I am going to prove whether I have to accept the null hypothesis or not. Otherwise, I have to go for alternate hypothesis, right? See, a hypothesis is a statement that either may be true or false. That is a simple thing I can say like that. So usually if you are going to start your research, so please frame the hypothesis with respect to your data set. And finally, once the analysis is over and verify it, whether your hypothesis is true or false, right? Then interpret your result. That is the actual way. Okay, fine. See, I have taken a data set. This data set is about related to election, right? With respect to the variable gender, I am having two instances of there, male and female. And another another variable is the party in which the male and female they are voted. That is three category: Republican, Democrat, and Independent. I think it's for US election, right? And totally 1,000 respondents are there. Okay, so the total male respondents are 400, and the total female is 600. Okay, let us see. So what is my hypothesis that I am framing right now is, from this data, I am framing the gender and voting preferences are independent. That is my hypothesis. So gender is one variable and voting preference is one thing. So I am relating there is no preferences. They are independent in nature. Like that, I have framed my hypothesis with some significant levels. Significant levels is very, very important. So once if you got the result, you have to compare with the significant level. Once a significant level is accepted, then only you have to accept or reject the hypothesis. So usually the research community for scientific research, they will choose the significant levels as 0.05, right? That means 5% of error, they will accept it, right? So 95% it has to be fine enough, right? That is the thing. Okay. So before going to start your chi-square test, right, you have to calculate the degree of freedom of your data set. How to calculate the degree of freedom? So this is the general formula. G minus 1 into V minus 1. That is, what is G? G is number of rows. What is V? Number of columns. I can say like that with respect to data science perspective. But with respect to social science, it's having its different story. Okay. So let us consider here G is number of rows and V is number of columns. So what is G? So two rows of information are there, male and female. So 2 minus 1. And V, how many? 3. Republican, Democrat, and Independents. 3 minus 1. That is 1 into 2. That is answer is 2. So my degree of freedom with respect to this data set is 2. And these are all my observed values. So now what I have to do to perform a chi-square test is I have to find out the expected value. So what is the formula for calculating the expected frequency count, right? Is the expected frequency count with respect to G comma V is, this is my general formula. Ng into Nv divided by N. N is the total instance, right? Ng with respect to rows. Nv with respect to columns. See here. First, I am going to find out with respect to male, with respect to Republican. Male, Republican. So what is the total value? It is 400 into what is, this is a total of male into total of Republican, 450. So 400 into 450 divided by N. N is my 1000. So ultimately I am getting value 180. Similarly, with respect to male, with respect to Democrat. So male is 400 and the Democrat is having 450. So again 400 into 450 divided by 1000. Again the value is 180. That's all with respect to Democrat. Next, a male with respect to Independent, right? So that is 400 divided by 100, 400 into 100 by 1000. So my ultimate value is, expected value is 40. Similarly, I have to do it for female also. That is 600 into 450 divided by 100. 600 into 450 divided by 1000. And 600 into 100. 600 into 100 divided by 1000. I will find out the expected value of all these male, female with respect to Republican, Democrat, and Independent. Okay? Yes. From the table, I know the observed values. So what is the formula of chi-square text? So chi-square x square equal to summation of observed value minus expected value the whole square divided by expected value. That is the general formula of a chi-square. So from the table, I can calculate the observed value. I can take the observed value. Previously, I have calculated the expected frequency count. So just by applying this thing, you can find out the value of chi-square. That's all. The problem is very simple. Now the problem becomes very simple. See, what is an observed value with respect to male Republican? 200. So 200 minus, what is its an expected thing? So previously I have calculated the expected value is 180. So putting it in the formula here, the 200 minus 180 the whole square divided by EGV. EGV is what? One or expected value 180. Yes. Plus, because it's summation. Plus. So next 150 minus 180, right? Divided by 180 plus 50. Okay. So in the next expected value, sorry. So the expected value is 40. I am just substituting it with the summation values. So this is the entire expression. Okay. Now I am doing some manipulation, and finally I got the z square value is 16.2. So I think it's a simple mathematics, dear participants, right? I will give the slides to you. You just verify it. Finally, you will get it 16.2 for this particular data set, right? So now you have to, there is a chi-square table will be there, right? Ready-made table will be there. So you just check it with the p-value. So the chi-square of 16.2 value is 0.0003. That is the chi-square value of the 16.2. So now I am going to compare this chi-square value with my p-value. So here my chi-square value is less than the p-value. So what I have to do, I cannot accept the null hypothesis. What is my null hypothesis that I have framed? I have framed gender and voting preferences are independent. So I have to reject my null hypothesis and I have to go for alternate hypothesis. That means gender and voting preferences are not independent. That means there is some dependency is there. There is a relationship between gender and voting preference. That's all about chi-square test. Once the data set is given to you, the simple thing is you have to find out the degree of freedom, and next you have to find out the expected frequency count, and finally the chi-square formula is there. You put it, you calculate the chi-square value and compare it with the table. Usually the chi-square table will be there. Whatever may be the value you are getting, you do it, you check it, some value will be there, and you compare that value with the p-value. If it is less than, reject the null hypothesis and you can frame your alternate hypothesis. Okay. So that's all about chi-square test. That's all regarding chi-square test. Next, as the one participant in the morning asked, sir, please show me some kind of a real-time case study like that. I prepared the case study for text analytics, I think tomorrow morning. So whatever may be the mathematics we have discussed, I will explain you all these stuffs, right? With respect to text analytics, there I am going to explain you how to find out one document is similar to another document. At the same time, if time permits, I will also explain how to do classification, document classification. So either it may be a binary classification, either it may be a multi-class classification or multi-label classification, right? If time permits, I will explain. I will explain all these things with the mathematics. So I am going to use cosine similarity for doing a document similarity analysis. I can explain how k-means, not k-means, naive Bayes algorithms are used for document classification. Again, if time permits, I will give an hands-on with respect to R programming, how to calculate document similarity analysis and document classifications using R. So that's all about today. I covered all the basic mathematics. So this is the agenda that I have fixed today. This,
Thank you, sir.
wait a minute, sir.
Actually, how?
Okay.
Yes, sir.
So foundation mathematics I covered, linear algebra I covered, statistics I covered, basic probability I covered, hypothesis testing also covered. Okay. So don't come to a conclusion that these are all the mathematics which is needed only for data analytics. So please, I request the participant to create some kind of an interest and please explore all these kind of mathematics. If you are really having any kind of doubts in mathematical modeling, you just text me. Surely I will help you in this regard. Okay. And tomorrow I'm going to give a I'm going to discuss about text analytics. Surely I think it will be interesting. Okay. So now any doubts, sir? Because time is already 4.
Sir,
Yes, madam, your voice is very feasible, madam.
now, sir? Now,
Madam, go ahead, madam. Go ahead, please.
like how chi-square test is used for finding whether two attributes are independent or dependent, sir. Like in attribute redundancy also we'll use chi-square test, no, sir. So how can we identify like two attributes are dependent or independent?
Kumar sir, the voice is very feasible to me. What about for you, sir?
Yes, sir, it's manageable, sir. I am hearing clearly.
So okay,
Low
you please interpret it, sir.
Low voice.
Low
She's
voice for
saying-
me.
Yeah. She's saying how to find the similarity between the two.
No, we are not able to hear.
That's why, sir, we are not able to hear her voice.
Yes,
Kumar
sir.
sir.
For me, low voice only.
Okay.
But I can understand how to find out the similarity between the two variables using the chi-square test.
That is the purpose.
So,
See,
yeah,
from the observed
so
value,
she-
from the expected
sir,
value.
Let me complete.
Okay.
He's saying we can use it for data reduction technique to eliminate the duplicate values.
Yes, once if you
Yeah.
find there is no relationship, we can eliminate,
Yeah.
obviously.
Yes. That's only
Yes.
she is asking how to find using chi-square.
Yes.
Whether those are correlated or positively
that's what-
correlated or negatively correlated.
Okay.
Or
Okay.
independent, like that. She
Okay. So if you want to check whether there is an independency is there between the variables, if you perform chi-square test, if there is an independence, you can have it that features. If there is no independence is there, if there is an independence there, then it's the duplication, right? You can go for a feature reduction, madam. Okay, that is my idea. But usually the chi-square test is used for checking the association between the variables. That is the relationship among the variables. I think some of them asked about the p-value. Before going to choose the experimentation, please fix the p-value. For our science community, the p-value is normally 0.05. Is an acceptable level. Sir, number of independent observation equal to degree of freedom. No. Degree of freedom is absolutely different, right? So with the degree of freedom only, we have to compare. You have to take degree of freedom and chi-square value. With this only, we have to justify our result with p-value. That is the normal interpretation. Ramakrishnan sir, I explain p-value. So p-value means the acceptance of error. That is 5% of error. If you choose the p-value as 0.05, that seems that 5% of error is acceptable. Okay. Your result is, it will lead to 95% accuracy.
Sir, Kumar sir, can I?
Yes, please, sir.
Yeah. Just to add to what Dr. Kumar Velan was telling, I think there might be confusion between p-value and alpha value. This alpha is also given as p-value. Therefore, normally in statistics, this 5% is called as alpha value. That is also p-value.
Okay.
That alpha value is fixed. That is level of significance.
Exactly, sir. Exactly.
In the softwares, when we run these softwares, we get the p-value. That is actual p-value that we are getting. We compare the actual p-value with this alpha, that is also p-value, with 5%.
Okay.
And if the computed p-value, that is the result from the software, is less than 0.05, we are going to reject the null hypothesis.
Absolutely correct, sir.
Yes. And then degrees of freedom is normally, row minus 1 into column minus
minus
1.
one.
That is your degrees of freedom.
Yes.
But if it is some other test like t-test, it is n minus 1.
Yes. Yes, sir. So it's depend upon the t-test, f-test,
Yeah,
like that. Okay.
depending upon the number tests, whether you have the row as well as columns.
Columns.
Yes.
Okay.
And can I, Kumar,
yes,
can I
please.
add one more thing?
So please go ahead, sir. Please go ahead.
Yeah. This chi-square test is normally used for qualitative variables. So,
Absolutely correct.
yeah, qualitative variables. Let's say one column variable is a qualitative variable. We are
That
talking
means
about,
categorical in nature.
yes, categorical in nature. So when you have found that the hypothesis is either accepted or rejected, we conclude, if it is rejected, we say that independent, what is this, alternative hypothesis is accepted.
Yes.
So at the time of formulation itself, we have to have null and alternative hypothesis, which are collectively exhaustible. Only these two possibilities should be there.
Yes. I think I have discussed all these things, Mallikarjuna, sir.
Yes.
Okay. So, whether the presentation is okay, sir?
Yes, perfectly fine.
Okay, fine. I think I did my business. Kumar, sir?
Hello.
Yes,
Yes.
Sir, this
Yeah,
is
in a short session, it is not possible to explain everything. We
Yes, sir.
understand that.
Yes. Thank you.
Yes.
Ramakrishnan, sir, please go ahead.
Yes, sir. Sir, am I audible?
Yes, you are clearly audible.
Okay, thank you, sir. Sir, actually, I would like to ask you the question.
Yes, please.
The number of independent variable is equal to the that is degrees of freedom. What I really means is, usually when you do any data analysis,
Okay.
we really wants to know that how many independent attributes are there. Because if we treat these attributes, independent attributes, automatically the dependent other observations can also be controlled. That sense only the degrees of freedom is developed. In that sense only, I'm asking that is it equal to the number of independent variables? But whatever discussion here is going on is depends on the formula, that is R minus 1, C minus 1.
Yes,
Everything is correct, sir.
Okay.
But my question is, what do you really means the degrees of freedom? Why I need to implement it in this particular situation?
So here I am, sir, say for example, I think some noise. Ramakrishnan, sir, the chi-square test with a formula only we have calculated everything. So by taking the degree of freedom into consideration, right, with a value of chi-square value, and while seeing it in the table value, and if it is matches with the p-value, then only we can come to a conclusion whether we have to accept the hypothesis or reject. Okay.
Okay, sir. Okay. Sir, sorry to ask you one more clarification. Because
Please.
I could explain the significance of p-value, but whatever the discussion here is going on is related to alpha and p-value.
Okay.
I strongly accept it, but my question is not in that sense.
Okay.
There are a lot of p-values we are calculating in multivariate statistical analysis.
Okay.
You know very well the p-value is lesser. Yes, we will get a more reliables on data.
Super.
In that sense only I'm asking, sir.
Okay.
What is the significance of p-value?
So depending upon the p-value only, we can say the accuracy of the model that we have developed. What kind of whether the data is in qualitative nature or not. Okay.
Yes, sir.
The name itself, right? The significance of p-value. Okay. So in social science, I think the p-value they will never choose as a 0.005, right? They will take some higher values. But regarding our scientific community, we will choose only, we will accept 5%. Rightly said by Mallikarjuna, sir.
Sir, even in social sciences, I think by default we normally take 5%.
Oh, fine.
Sometimes even 10% is
10%,
acceptable.
yes, 10% is acceptable.
Yes,
Okay.
yes.
That's why.
Sir, one more point, sir.
Yes, please, sir.
Excellent distribution actually you have shared with us, that is called chi-square distribution.
Okay.
Since I'm doing some research in that, I would like to add one more point.
Please go ahead, sir.
So, you know, lot of distributions. Distribution is one kind of fitting a curve, fitting a data. Both discrete or continuous distributions.
Yes.
You know very well the chi-square distribution is the best distribution to select whether our discrete or continuous distribution is suitable to the data or not.
Okay,
More
okay.
chi-squared value will give less reliable on the distribution. Less chi-squared value will give the more reliable. This
Very
is
nice
what I
interpretation,
understand.
sir. Very nice interpretation. Thank you.
Sir. Thank you.
Thank you. Thank you. At the same time, even while taking the distribution, I can touch upon normal, Poisson, binomial, everything. But it becomes too much of mathematics, you know. I think it will be get bored also. That's why I have not touched that one.
Yes, sir.
Otherwise, I will focus on distribution too.
Yes, sir. I
Okay.
strongly agree then. Thank you.
Okay.
Good discussion regarding the chi-square value. Participants, any more doubts?
I will share my PPTs, Kumar
Yes,
sir,
sir.
surely.
Yes, sir. Yes, sir. Sure.
And please distribute
I'm
to the
just
participants.
checking the chat box. Is there any questions?
Okay, okay, okay. Myself also, I will do the same thing.
Yeah. Okay, sir. Nothing is there. I think that's
okay. So tomorrow regarding text analytics.
Yeah. Tomorrow, sir, have one more session on the text
Okay.
analytics and classification.
Okay.
So if there is no doubt, so we will wind up the session today and we will join tomorrow morning, 10 o'clock. I think
Okay, sir.
it's better to join five minutes before. Okay. So participants, if you have no more doubts, we will wind up the session. Okay.
Thank you, sir. Can I leave?
Yeah, sir. Yeah.
Sir, excuse me.
Some
I have a
question.
question.
Yeah. Ask.
Yes, Anshika.
Yes, sir. Sir,
Yes,
as you
please.
told in group frequency distribution,
Group
I was
frequency.
yes, sir. So just
Yes.
I want to ask that the number of classes, like
Yes.
we have to assume it or we have to use the formula for it.
No. Say for example, number of classes, there is no thumb rule. You can choose from 5 to 20. Obviously, in this example, I have chosen 7. Okay. There is no thumb
So,
rule.
but I have studied a formula where we.
Yes, please go ahead. Please go ahead, madam.
Sir, it's 1 plus 3.322 log 10 n.
Okay, thank you. Can you please text that formula in text box?
Yes, sir. It
Because
was
I
in
can
the Gupta and Kapoor book.
Okay, fine. Fine, madam. I will just refer it. Tomorrow I will clarify this matter, madam. Okay.
Okay, sir.
Sir, please type your mail in the chat box so that anybody wish to communicate, they can communicate regarding any doubts. Kumar Velan, sir.
Yes, I am doing, sir.
Yeah. The participant takes the mail ID, and if you have any doubts, you can contact the sir. Tomorrow also, sir will handle one more session on text analytics and classification. So we can ask tomorrow also.
So tomorrow I am going to focus on NLP part, natural language processing, and at the same time cosine similarity, and I will touch upon some supervised learning models.
Okay, sir. Okay.
That's all.
Sure. Thank you, sir. Thank you very much.
Thank you very much,
for your nice session.
Okay.
Participants, thank you very much for your cooperation and patient listening and your curiosity about the subject. Okay, thank you all. We'll meet tomorrow. Still, if you have any doubts, you can ask me. So attendance is taken automatically. So if anybody is using other than Gmails, they can confirm whether their attendance is recording or not. Okay. You can call Manas. Manas number is given in the mail. So you can call Manas or you can mail to the Manas or to me so that we will clarify if you have any doubts further. Okay. Thank you guys. Thank you all. So we'll wind up the session.
Thank you, sir. Kumaran sir, how are you?
Fine, sir. Fine, sir. Thank you very much, sir, for you are actively participating in our program. We are very happy. We are very happy by seeing you.
Thank you, sir. Yes. We'll meet tomorrow.
Come, sir. Tomorrow, daily come, sir. Daily join our meeting.
Yeah, I'm joining. But
Yes,
text analytics, I don't know how much I'll understand because I'm not at all familiar with this, but I'll enter.
There also mathematics is there, sir. Text analytics also.
Yes.
Higher level only text, lower level mathematics only. Sir will explain.
Okay. Nice. Thank you, sir.
Okay, sir. Thank you. Whether my attendance is recorded or not. What is your name, madam? Madam or sir?
Was Ramakrishna was asking whether my attendance is recorded or not.
Oh, Ramakrishna. Whether you are using Gmail or other institutional mail, sir? Ramakrishna, please unmute and tell. Ramakrishnan, sir. Manas, you check once whether yesterday it is recorded.
Yes, sir. I'm checking, sir.
Ramakrishnan. Anybody is joining a different names other than the registered name also, you just inform, because we don't know if you join with a different name. We have only registered names. Is there, Manas?
Sir, his attendance is recorded, sir. Ramakrishnan K.
Just a minute. Today is 10th, na? Okay. Also for Ramakrishna. Ramakrishna, today spell. Yesterday also same name. Today I didn't find this name, Ramakrishna. Is there any initial? Is there only Ramakrishna?
Sir, it is Ramakrishnan K.
Ramakrishnan K. Ramakrishnan also not there. This is today second session, 11:50. I think he not attended second session. It's not there. Second session not attended. Second session he is not attended. Is it right, Ramakrishna? He is not there, Manas. Second session he is not there.
Oh, okay, sir. Okay.
Okay. Okay. We'll stop recording and I will stop the session.